Welcome to the Salmon Runs YouTube. Enjoy the video.
In this video, I will compare bubble versus insertion sort. We'll begin by defining each sorting algorithm, understanding their fundamental approaches to ordering data. Then, we'll establish the key criteria for our comparison, focusing primarily on their efficiency in terms of time and space. This will help us determine which algorithm is more suitable for different scenarios, providing a clear understanding of their strengths and weaknesses. Bubble sort is a simple algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. This process continues until no swaps are needed, indicating the list is sorted. Its worst case and average case time complexity is O, n squared, making it inefficient for large datasets. However, its space complexity is O, 1, requiring minimal additional memory, which can be an advantage in very constrained environments. Insertion sort works by taking elements one by one and inserting them into their correct position within the already sorted part of the array. Imagine sorting a hand of playing cards. Its worst case and average case time complexity is O, n squared, similar to bubble sort. However, it performs exceptionally well on nearly sorted lists, achieving O, n in the best case. Like bubble sort, it boasts a space complexity of O, 1, making it memory efficient. When comparing bubble versus insertion sort, both share an average and worst case time complexity of O, n squared. However, insertion sort consistently outperforms bubble sort in practical scenarios, particularly with small or nearly sorted datasets, requiring fewer operations. Bubble sort is largely considered inefficient and is seldom used in real-world applications. Insertion sort, conversely, finds utility in sorting small arrays or as a component within more advanced sorting techniques, making it the generally preferred choice.
Thanks for watching. Consider subscribing if we helped you.